Good morning. This is Ms. Billerbeck, and we're going to talk about 1.2 solving linear equations. So Ella's going kayaking. She has $55. How long can she kayak if a sit on top is $15 an hour and a sit inside is $18 an hour? So let's see what is her best option. Well, we know the sit on top's her best option for the money, but let's see if she can squeeze in that sit inside. Okay, so how would we set this up? Well, she has $55. So, and we know it's $15 per hour. So if we write $15 per hour and follow our units and then multiply by hours, but let's make H hours, because we should keep the variable more in line with what it means. So instead of using a parentheses right here, let's use an H. Okay, so we have $15 per hour times H is going to equal $55. Okay, so this is the same thing as 15H times 15H equals $55. And then if we did the same with the sit inside, it'd be 18H equals $55. Now, in both cases, we would use a multiplicative inverse to solve for H. Oops, this one's 18, and then that would be 18. So 18 divided by 18 is 1. 15 divided by 15 is 1. If we do something on this side, we do the same thing on this side using a multiplicative inverse. Okay, so that cancels this 15 and this 18 and that. So now our two equations are H equals, and let's see, 15 goes into that. 3 times 15 is 45. So we have 3, and then we have 10 left over. So 10 over 15 is 2/3 hours. Okay, so that would be 3 hours, and 2/3 hour, if a third of an hour is 20 minutes, that's 3 hours, 40 minutes with the sit on top. Okay, so let's look at this one. So if I have H here, 18 times 3 is 54. So I have 3, and then I have 1/18 of an hour. Okay, 1/18, if 1/20th of an hour is 3 minutes, then 1/18 might be 4 minutes. Okay, so we have 3 and 1/18 here. Okay, hours. So we can write on either one depending on what we would like. But what if there's a one-time life jacket rental fee? Because you might bring your own life jacket that fits you nicely and is a nice kayak life jacket versus the ones they rent. But let's say you didn't bring one and you can't kayak without a life jacket, so there's a $5 fee. Okay, so we would set that up a little differently. So for the sit on top, it would still be $15 an hour, but then we had to add $5 equals $55. So that's how we'd set up that one. The other equation would be the $18 per hour. So then we multiply by the number of hours plus the $5 we have to pay, and it has to be $55 or less. So I guess I could have said this. It needs to be $55 or less. There you go. And same with this. This could be less than or equal to. There you have it. Okay, so actually we did an equal, so I'm going to leave it that way. All right, so we can only, well, yeah, so anyway, when we solve this, we're going to subtract our $5 from both sides. So that gives me 18h is less than or equal to 55. And when we divide by 18, we have a little problem there. Okay, that means that if we can only rent it for an hour and not part of an hour, then that means that 3 times, whoops, this is 50 now. 3 times 18 is 54. So now we can only spend 2 hours out there if we can't rent partial hours. Okay. And then this one here, 15H is less than or equal to 50. Well, this one I can still rent it for 3 hours because 3 times, when I divide by 15, H is going to be less than or equal, and that's going to be 3, and then it's got 1/3. So 3 1/3 there. So if I can rent it for an hour, only hours, I can rent the sit on top for 3 hours still. Whereas the sit inside, I can only rent it for $18 an hour. All right, so that would be how we use algebra in our real life so that we don't get charged penalties for going way too late and having way too much fun kayaking. Okay, so example 1. Let's solve for x. Now this is the normal version of algebra using abstract numbers. Okay, but it prepares you for situations like renting kayaks. Okay, so what I'm going to use is an additive inverse and move this over to its like term over here. Okay, and remember we have a balance bar going on here. So whatever I do on this side of the equal sign, I do on this side. So that's 0, and then I have plus 3x minus 1 over 2 equals 5. Okay, I want to get rid of this 2 down here, so what I'm going to do is a multiplicative inverse on both sides. So I don't really need the 0 here anymore. So I'm going to multiply by 2 on both sides, which cancels that out. And I have 3x minus 1 equals 10. Okay, again, I use an additive inverse. And I get 3x equals 11. So now my final step, I'm going to use a multiplicative inverse here. And I'm going to get x equals 11 over 3, or that's the same thing as 3 2/3. Okay, so that's how we would solve that type of equation using an additive inverse, a multiplicative inverse, an additive inverse, a multiplicative inverse. All right. Look at example 2. Now this example is quite the favorite in most books, so please pay attention. Okay, the sum of 3 consecutive odd integers. So we know that if we do 2 times n, anything times a 2 is going to be even. Okay, so if we want it to be odd, we're going to do 2n plus 1, or 2n minus 1 would be odd. Okay, so either way, we could get an odd number there. So that the same would be 2n minus 1. That could be another way to write an odd. Both ways work. Okay, so we have 3 consecutive. Now consecutive means next to. So that's like 3, 5, 7. 1, 3, 5, like that. Okay, so they're just next to each other, consecutive. So what that means is our first term, it asks if you add them up, so the sum You add them up, it's going to be 57. So we need to define our terms so we don't get lost when we find our answer. So if we say our first term is going to be 2n, and let's just do -1 to get it started. Okay, and second term, we're going to add 2 because odd numbers are 2 apart. So when we add 2 to -1, we get +1. And the third term will be 2n, and that'll be +3. So those are our 3 terms. They're 2 apart. So now we know that 2n minus 1 plus 2n plus 1 plus 2n plus 3 equals 57. I'm going to move this right now so I have more room. So that equals 57. Okay, since we're doing addition, the parentheses really don't matter. So let's get rid of these parentheses. I was just doing that for emphasis that these are our 3 terms. Okay, and with addition, that it doesn't matter so much to have the parentheses or not. All right, so I have 2n. If I organize my like terms, 2n plus 2n plus 2n. So I've got that one. This is my little accountant thing. I got that one and I got that one. So then -1, boom, +1, +3 equals 57. So now I simplify. That's 6n, and -1 plus 1, 0, plus 3 equals 57. Okay, so I use an additive inverse on both sides of my equal sign. What I do here, I do here. And then that's 6n equals, and that's 54. Okay, so I divide by 6 using a multiplicative inverse, and I get my first number is n equals, it's not my first number, it's just n. So I need to be clear. So 54 divided by 6 is 9. So I said my first term was 2n minus 1. So the first term equals 2 times 9 minus 1, which is 18 minus 1 is 17. The second is 2 times 9 plus 1. So that's 18 plus 1 is 19. The third term is 2 times 9 plus 3. So that's 21. Now I check because that's a very smart thing to do. So that's 17 here and it's 57. So it checks. Okay. So on this, it's very important and easy to check. Okay. So that's how we would do this problem using algebra and making an equation. All right, this is another favorite problem that will always pop up, so we must understand this one. Now, I borrowed this one from, I think it was even Algebra 2 brought this up again. So I just really like this chart format. It's not in your book, but I like the charts and how they organize. So we have a lab technician and needs 30 liters of 25% acid solution. How many liters of 10% and 30% acid solutions are needed? Okay, so we don't know the amount that we need for solution 1, but we do know that solution 1 is 10%, and we can write 10% as a decimal. So when we multiply that together, that's 0.1x. Okay, solution 2, well, we know the total solution of the new solution is 30. Let me write that nicely. Is 30 liters. So we're going to have 30 liters minus whatever we used of the 10% acid solution. And then that solution quantity was the 30% acid solution. And then our goal is to have 25% solution. So we want 30 liters of 25% solution. And we've got our 10% acid solution. We don't know the quantity, but so we wrote X. We have 30% acid solution, and whatever is left after we subtract X from 30 is our 30% acid solution. So we're going to write 0.3 times 30 minus X. Okay, and then this one is just 30 times 0.25. Okay, so we should be able to add this all together and set it equal to this. So what we're going to do is add the first solution to the second solution, and it should equal the solution we want. And we know that when we multiply this by 30, that is 7.5. Let's do that again. Yeah, that's what it was. Okay, so 25, 30, multiply 0, 15. Yep, that's it. And it goes right there. Okay, 2 decimals. Okay, so 7.5. All right, so now we distribute here. So we have 0.1x plus, and then 0.3 times that is going to be 9. Okay, so let's do that on our dry erase calculator really fast. So we had 0, 9, and 1 decimal over. Okay, so just in case you missed that. Okay, and then minus 0.3x equals 7.5. Okay, let me get another board here. Oops, that's not the board. There we go. Okay, so let's get some more room here. Going to be a long problem. Okay, so we have 0.1x, and then it's minus 0.3x, and that's going to equal, and we have, if we subtract the 9 on both sides, okay, that's minus 1.5. Okay, so this gives us negative 0.2x equals negative 1.5. We divide by 0.2, negative 0.2. Okay, so on this, since we both, if we want to do this nice and easy, this one we can move the decimal on both of them, so it's 15 over 2. So then we have x equals 7.5. So we're going to use 7.5 liters of the 10%, and then the other solution is going to be 30 minus x, which is 30 minus 7.5, which gives us 22.5 liters of the 30% solution. Okay, so that's what we're going to mix together to get our new 25% solution. Okay, so let's look at the next problem. Find a spot for these two. Okay, another favorite in algebra is buying tickets. Okay, so let's see how we're going to work this one out. So we have 4 friends and they buy tickets for 2 shows on consecutive nights. Okay, so 4 friends, 2 shows, that's 8 tickets. Okay. They use a $5 off coupon, so they have a discount of $5. Okay, for each ticket. They pay $416. I'm going to take this off because it looks like a blob and it doesn't look like a dollar. Sorry about that. Okay, so they pay that amount. So we don't know the price of the ticket. And we know that they did pay, so they paid X minus $5. And they paid $416 with their discount. So we want to find the original price of the ticket. So, so we know we have 8 people, 8 tickets. So sometimes if we write the verbal model out, it works well. So we've got 8 tickets times the price, discounted price of the ticket. Our discounted ticket equals $416. So there you have it. So we have 8 times the discounted ticket is here. So we shouldn't use times with an X because now we're using X for a variable. So let's use a dot for multiplication. And X minus 5, and then that's going to equal 416. So when we distribute this, we get 8x minus 40 equals 416. Okay, so we're going to add 40 to both sides. And that gives us 8x equals 456. So let me write that here. 8x equals $456. So then when we divide by 8, our original ticket is going to be, there's 5 8s and 45, and then 56 is 7. So each ticket was $57. Okay, and again, we could check that. So if we take $5 off 57, that's 52, multiplied by 8, and that gives us 16,416. That's a check. Okay, so please check your work, especially when you're on the test. Okay, this was a nice problem here. Okay, so we have LaTanya leaves her house at 12:30. So we have LaTanya's house. I say LT. So she's got this house here. Pictures speak more than 1,000 words. So then she goes over here to her friend's house. And that friend is Marta. Okay. So she leaves at 12:30. And she gets there, we don't know what time, but she's moving 12 miles per hour on her bike. So she leaves her house at 12:30 and bikes at 12 miles per hour to Marta's house. She stays at Marta's house for 90 minutes. 90 minutes, which is the same thing as 1 hour over 60 minutes, which gives us 1.5 hours. So if we're doing miles per hour, we need the time in hours. So both girls walk back to the house. Okay, and they are doing the same route at 2.5 miles per hour, and they arrive home at 3:30. So their total time gone from the house is 3 hours. Okay, so we're going to have two variables. So first of all, we know that the distance they traveled is the same, and they want to know the distance. How far are these homes apart? How far is Marta's home from Latanya's? Okay, so we know rate times time 1 will give us distance, and the distance is the same. And this one is rate. Let me move this one over just a tad. So 2.5 miles per hour times time 2, because it's going to be a slower time because they're walking. And that's going to be the same distance. D1 and D2 are the same. So now we can set those two equations equal. Get another cord because this is going to be a big problem. Okay, so we have T1. Now let's do 12T1. We should always put the number in front of the variable. T1 is not T squared or T to the first. It's a name. So this is a subscript saying this time is different than T2. Okay, that's the time 1, time 2. So subscripts are used to differentiate variables that mean the same idea, but they aren't the same value. So this is the idea of time. So 12 times T1 equals 2.5 times T2. Now we can isolate this by dividing by, let's divide both sides by 2.5. And what that does is it gives us the equation in terms of T2. Okay, so if we have two variables, we need two equations. Okay, so we also know the total time that they traveled. So they went 1:30, 2:30, 3:30, so 3 hours. Okay, so let's look at what equation we can come up with that. So they know that they took a certain amount of time, T1. And then they added 1.5 hours at Marta's house. And then they walked T2 time. And that total time added together was 3 hours. Okay, so we're going to move this 1.5 to the other side. And we have T1 plus T2 equals 1.5 hours. Okay, so we have one equation here, T2 equals 12 divided by 2.5, 2.5 into 12. So we have 12 T1 over 2.5. And so that's one equation. And we have our second equation. So we have our two equations and we have two variables. So now we're going to put this into this equation here. So we have T1, we're going to use substitution and put this T2 and for this T2 is 12 T1 over 2.5 equals 1.5. Okay, so if we get, let's look at what is 12 divided by 2.5 here. It's 4.8. Okay, so we have T1 plus 4.8 T1 equals 1.5. Okay, so I have 1T plus 4.8, so that's 5.8 T1 equals 1.5. Okay, so now I'm going to use a multiplicative inverse and divide by 5.8. And I get T1 equals, and I have 1.5 divided by 5.8 gives me 0.259 hours. Oh, isn't that precious to work with? So we want distance. Okay, so we know that distance times time, or we know that rate times time equals distance. That's what we've been doing. So we go back to our first equation up here, 12 times the 0.259 to find our distance, which is, so times 12 gives us 3.1 miles. And don't forget your units because miles and inches are very different. Okay, so that's how we would solve that type of problem. All right, I hope that answers your questions for the homework. If not, please ask me for some help when you're doing it. All right, have a wonderful day. Bye-bye.